Start Concavity with you. Also attached to this email is a little more average rate of change practice. So I give you the worksheet and then the answer key to it. That way you can actually self-correct on that because it seems like you have a good grasp of it. That average rate of change is going to show up on the next quiz as well. But concavity is new. So I want to talk about that. Concavity tells us how a curve looks, right? And right here, see how this is a sad face, like kind of like a parabola in here? This is what we consider concave down, right? The curvature is looking down. As opposed to this side of the graph, see it's like a happy face parabola? That would be concave up. And that's what we're going to be talking about, the concavity. So this area in here is concave down, so CD. And this area in here is concave up. And then what we can do is break it down into sections and talk about it. For the graph below and for the given intervals, determine whether it's increasing, decrease, as well as its concavity. So from A to B, and we're always moving from left to right, as we're going from A to B, notice the graph is increasing. So we're going to write increasing, right? But the curvature, and I already wrote concave down in there, is downward. So that's why it's going to be concave down, right? Now, from B to C, right, we're not going up anymore. Now we're headed down, so this is decreasing. However, the curvature is still downward, so it's still concave down. Okay, from C to D, we're still going down. The graph is still going down, so it's still decreasing. However, look at the curvature now. It makes a happy face parabola, so that's going to be concave up. I'm going to bring in one more vocab word. I'm going to talk about point C right here. All right? At point C, if you notice it used to be concave down and now it's concave up, that is what we call an inflection point, because the concavity is changing. All right, and finally, from D to E, the graph is now going up, so it's increasing. And it's still a happy face parabola, so it's still concave up. So that's how you figure out concavity from a picture. It's pretty straightforward. But what if you don't have it a picture, you just have points? All right. Given the chart below, determine whether g of x is increasing or decreasing and its concavity. The way you tell is through average rate of change. So what we have to do is the average rate of change. Average rate of change helps us determine concavity. Right? So as soon as you talk about concavity, increasing, decreasing, we're going average rate of change, which is slope, right? So I'm going to do a couple. I always do 3. So I'm going to do change y, so negative 3.1 minus negative 5.7. So change in y over change in x's, right? So I'm going to do that negative 3.1 minus negative 5.7. So that makes 2.6 in the numerator. 2.4 minus 1.5 is 0.9. 2.6 divided by 0.9. So I'm getting 2.8 repeating. All right, to the next one. Negative 1.4 minus negative 3.1 all over 3.6 minus 2.4. So negative 1.4 minus negative 3.1. 1.7, 3.6 minus 2.4, and then I'm going to divide those. All right, I'm getting 1.416 repeating, and finally 0 minus negative 1.4 all over 4.8 minus 3.6. So that's 1.4 over 1.2. And I'm getting 1.16 repeating. All right, so just going to bang those out real quick. Now, a couple of things are figured out from this. First of all, look at your 3 average rated changes. They are positive. And that means it's an increasing function. So you write a sentence. Since the average rate of change is positive, it is increasing. So increasing and decreasing, all it matters is if these are positive or if these are negative. It'll never be a mix. The level you're at, we usually have it one or the other. So if all 3 are positive, increasing. All 3 are negative, decreasing. Now look at the value of the numbers. The value of the numbers are getting smaller. You see that? That was 2.8, 1.4, 1.6. The numbers are going down. So since the value of the average rate of change are decreasing, g of x is concave down. Okay, so if these numbers are getting smaller in value, concave down. If these numbers are increasing in value, it would be concave up. All right, so let's check out this one. Determine if it's increasing, decreasing, and its concavity. So I'm going to do the average rate of change. So 0 minus negative 5, 4 minus 1, that's 5/3. Okay. 10 minus 0, 10 minus 4, it's 10 over 6, which just reduces. Okay. 15 minus 10, 13 minus 10. All right, check this out. Now, first deal, all 3 of these numbers are positive. So since the average rate of change are positive, it is increasing. So if the average rate of change are positive, increasing. If these were negative, decreasing. Now, look at the value of these numbers. They're all the same. That means the average rate of change is constant, and the only time that can ever happen is if there's a line, and that means there's no concavity. So since the average rate of change are constant, there is no concavity, because it is linear. Okay, so to recap, anytime we ask about increasing, decreasing, or average rate of, or concavity, you do the average rate of change. If it's positive, increasing. If they're negative, it's decreasing. Concavity has to do with the numbers themselves. If the numbers are going down, it's concave down. If the numbers are going up, it's concave up. And if they're all the same, there's no concavity because it's a line. All right, and there's some actual book questions that go along with this, which I'm going to have you try. And then when you're done with those, let me see what you get, and we'll go from there.